Welcome. Today we will be going through an adaptation of question 6 of the Maclaurin Olympiad 2010. I want to write a number on a blackboard consisting of 1s and 2s. I want there to be 12 digits in total. However, each number cannot have 2 consecutive 1s. How many such numbers can I write? For example, 222, 222, 222, 222 is valid, but 111, 222, 222, 222 is not, and 222, 112, 222, 222 is also not valid. Please pause the video here and have a think about the problem on your own before proceeding to the hints and solutions. Hint number 1. Have a look at the possibilities for the first few digits. Can you notice a pattern? Hint number 2. How do the previous digits affect the possibilities for the upcoming digits? Hint number 3. After a while, you will notice a pattern. Can you prove it? Solution. For the first few two digits, the possibilities are 22, 21, and 12. For the first 3 digits, the possibilities are 222, 221, 212, 121, and 122. As you may have already noticed, if the previous digit was 2, the next digit can be 1 or 2. If the previous digit was 1, the next digit has to be 2. So now we look at how we get the new digits, the new numbers. So when we have 2 digits, we see that 2 of them end in 2, i.e. 22 and 12, and 1 of them ends in 1, 21. For each of the numbers that end in 22, we get 2 possibilities. And of these, for each number ending in 2, we get a new number which ends in 1. However, we never get a number ending in 1 if the previous digit was a 1. For example, 21, we never get 211. So the number of new numbers ending in a 1 would be however many previous numbers ended in a 2, and the number of new numbers ending into 2 would be however many previous numbers there were. So we will generalize this with the following notation. So the first number will be the number of numbers ending in 2, and the other number will be the number of numbers ending in 1. Might sound complicated, but hopefully after a few examples it should be easier. So for the first digit, we have 2 options, 1 and 2. So one of them ends in 2 and the other ends in 1. So we have 1, 1. For the first 2 digits, we had 22 and 12 ending in a 2, but only 21 ending in a 1. Similarly, for the first 3 digits, we then have 3 and 2. And the way we keep generating more and more is for the last number, it will be however many 2s there were. So as you can see, for the first 2 digits, we had 2 for 2, so we will have the next one 2 for 1. And then for the 2s, it will be the sum of the numbers. So for example, 2 plus 1 is 3 and 2 is 2. So the next one will be 3 plus 2, 5 and 3. And then the next will be 5 plus 3, 8 and 5, 8 plus 5, 13 and 8, etc, 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 until we get 233, 144. All this will tell us is that we'll have 233 12-digit numbers ending in a 2, and 144 12-digit numbers ending in a 1, and so 377 12-digit numbers in total. If this was a bit confusing, try and go back. It should after a while get easier once you've seen a few of these problems. It is a combinatorics problem after all. They can sometimes be intuitive, sometimes not, and the more you solve them, the easier they'll get. And the reason why we had Fibonacci in the thumbnail was because, as you can see, all the numbers here are Fibonacci. So if we had the digit length being 100, the answer would be the 100th Fibonacci number. Anyways, thank you for watching. Please leave a like if you enjoyed this video, and feel free to drop a comment in the comments down below. And yeah, goodbye.